Yo, what's up? I'm Ian255, and today I've been thinking a lot about ABACABA patterns, and specifically the relationship to exponentials. And I'd like to share what I've been looking at with you today. Now, I suppose the first question I'll have to answer is, what is an ABACABA pattern? Now, you may know, you may not, you probably don't if you're watching this video, but put simply, ABACABA pattern is basically this little sequence of letters you can create by following a process over and over again. So I'll show you how to do it. First of all, you start off with the letter A. Fairly simple. Now to create the next sequence, set of characters in the sequence, you take what you have already, that's A, you have two of them, and then you put the next letter in the alphabet between the two of them. Now the next one after A is ABBA. If we were to do this again, ABBA, ABBA, and between the two, autocorrect, between the two ABBAs we would put a C. And if we were to do it again, ABACABA, put a D between the two, and then our ABACABA. And you can repeat this as long as you want, but you can see it gets long, and it gets long quickly. It starts off with just one letter, then it goes 3, then 7, then 15. How long does it get? Well, for that, we're going to use this Python script that I made. It's a short little thing, and basically it creates an ABACABA sequence up to the letter that you put in it. So say if I put in A, it will give me A out, since that's ABACABA up to the letter A. If I put in F, I'll get the ABACABA pattern all the way up to the letter F. Now, you might be wondering, okay, but it doesn't get too long though, does it? I mean, there's only 26 letters in the alphabet, it can't get that long, surely. Surely not. I mean, surely it doesn't get that long going to the letter Z. Holy Jesus. And you think that's bad? My scrolling is barely doing anything. Now remember, there's only one letter Z in there. Yep. It gets very, very, very long. I'm actually going to stop scrolling now, because surely you don't want to see that. Instead, you want to know exactly how long it gets. And for that, we're going to use a calculator. And we're back in the calculator again. Don't know how many of these videos are going to end up revolving around this thing. So, you may be wondering how you can find out, given that you know what letter you want your ABACABA sequence to go up to, you may want to know how many letters that ABACABA sequence will contain. And for that, well, let's just look at a few examples. First ABACABA sequence to the letter A has one letter. Second ABACABA sequence has 3. The third one has 7. The fourth one has 15. Are you noticing a pattern yet? The fifth one has 31. Sixth one has 63. And the seventh one has 127. Okay, you might not have noticed the pattern. I don't blame you if you didn't. It's actually to do with the little thing hidden under the second function on this calculator, 2 to the power of x. See, if you check 2 to the power of x, if you do 2 to the power of 1, that is 2. That's normal. 2 to the power of 2 is 4. Also normal. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. Are you noticing the relationship between this and our ABACABA letters? Yep, it's take away 1. So, to find out how many letters you have in your ABACABA sequence up to a certain letter, you take that letter's position in the alphabet, do 2 to the power of that number, and then take away 1. So if we want to know, say, how many letters there are to F, we take its position, 6. We do 2 to the power of 6, and then we take away 1 to say there's 63 letters in an ABACABA sequence to the letter F. If we want to find, to say, the letter O, we do 2 to the power of 15, because O is the 15th letter in the alphabet. Take away 1, and we find out that there is 32,767 letters in an ABACABA sequence to the letter O. And if we do it to the letter Z, the 26th letter in the alphabet, don't forget to take away 1, make it a lot more respectable. We see that a full ABACABA sequence of all letters of the alphabet contains 67,108,863 letters. Oh my goodness. That shows that the ABACABA sequence gets big very, very quickly. And it also shows the rapid growth nature of the 2 to the power of x function. To further illustrate this, I'm going to show you a graph of this function that we've been using. Oof, finally, we are in Desmos graphing calculator. This is a graphing calculator, as the name would suggest, where you can put in functions and see their graphs. So we're going to put in that function we were using in the calculator, 2 to the power of x minus 1, and see how it looks. You can see here what it looks like. See, for the letter 0, it is 0. For number 1 even, I can't believe I just said letters. But for the number 1, it outputs 1. The relationship with what we were using is that the x coordinate is the number we would put in, and the y coordinate is what would get outputted. For example, for the number 3, we would put 3 in, and our y coordinate is 7, showing that the output of 2 to the x minus 1, if we put in 3 as x, is 7. Now let's look at the graph. You can see it cuts through 0. It's negative at negative numbers, although it doesn't make sense at negative numbers. And look how steep it is. It reaches 200 before it's even made it past 10. That is just extraordinary. And it shows why we see the rapid growth in letter numbers and ABACABA patterns that we do. It's all because of the exponential nature of 2 to the x minus 1. Oh, this has been an interesting one to make. I hope you've enjoyed it. I've definitely enjoyed it. Switching between all those apps and discussing all this stuff. Longer video than most videos have been so far, and hopefully more videos will be like this in the future, but I suppose we'll find out in the next couple of days. In the meantime, the only thing I can promise is that I will be uploading again tomorrow, and I hope I see you there. For now, it's been day 6 of 365 days of the Insular 255, and I will see you tomorrow.